Just hoping to clarify the restrictions on recursion during the bonus project. For example, we're supposed to write the initial program parser, and I was hoping to still be able to do two separate parse functions.
Okay. So the recursion. Okay, here's what it is. So the you can do recursion absolutely in your parser, right? Just like on Project 5, you are doing a recursive parser, right? Because you're parsing the main body, and then when you get to like a while statement, you have to call parse body again to parse that body, and if that has any while statement, you call parse body on that, right? So your parser is definitely recursive. It's you can't make the compiler backend recursive, right? Because you're trying to support these expressions, so you can't change the compiler backend to be recursive. Like you can't tell the compiler backend to just recursively execute these things.
I thought we weren't allowed to do that at all. Not just for the bonus project.
Yeah, no. For the bonus project, you may need to change the backend, which is fine, but you can't change it to make it be recursive or to call other functions.
Okay. I was really confused on how to do it.
Got it. No. That's a good clarification. I'll try to send something out on the mailing list.
Okay, it's when I saw the emails and read the project, I thought we just weren't allowed to use any recursion, so I was like, how am I supposed to do this iteratively?
No. You don't want to do it like that. You want to use recursion for parsing.
That's why.
Other questions? Project homework 4 or bonus project 5 questions?
I'm not going off.
Yes. Okay.
Also email them.
By the way,
Get most of your friends.
so I want you to think about it like this, right? So part of what understanding the types, what they are, right, in a program means that you know how to call that function, because you can create a function of that type or an array of that type, and you can pass it in, and the compiler can check if what you're using passes that, right? So the question you should ask yourself is, can you create a type, like a variable with a type, or a function with a type, if it's within the function? So, for instance, right, so let's say, let's do a super simple example of this thing's not plugged in. No. Oh, there you go. Yeah, why it takes like an hour to do that, I have no idea. Okay, let's say we have some function foo, right, that takes in an A and a B. Or what's define? Are you using define or fun? I think it's fun. Okay, right? Let's just say A plus B. Right? The type of foo, right? We don't know. We have no constraints on the type of foo, but we know that the type of foo has to be a function that takes in, let's say, T1, right? And a T1, and returns a T1, right? We don't know what those types are. They could be any type, but they all have to be the same. Which means, if you want to call function foo with, let's say, variables D and E, right? So if I say D is an int, right, and E is like a string,
That will cause problems.
right? This will cause problems. This cannot happen, right? But if I wrote it like this with an int, can I do that? And then do I know what the return of this function call is going to be? An int, exactly. So, can you, so let's think of, let's think of some other way. Let's think about type errors in a different way. So let's say I had a new we'll use foo again because I'm sick of coming up with names. Let's say we had return, let's say, right, let's return A plus 1 plus, let's say, plus B plus LO, right? So now what are the type, so if you tried to type check this, right, you get A is an int and B is a string, but you get that A and B are the same. right? And so B has to be a string and an integer at the same time, right? So the problem with why this is a type error is because if I wanted to call function foo with some new variables D and E, right? What are the types that I give these variables? Right? Like a variable cannot be both an integer and a string. Like there's no possible type I could write here for what these types of D and E are to allow this to occur.
So, so if you have two functions, like same parameters and same return value, would those be functions of the same type?
So if I have, say that again?
Like let's say you have a functional fleet function that has two parameters int and int, and then that returns an int. You have a function with the same parameters int and int, would those functions be the same type?
Could you use those functions anywhere? Could you use them interchangeably? Right, so it's actually similar to thinking about classes, right? It's like if I expected a bar, could I pass a Baz?
Yes.
Yes, because I know everywhere that Baz is used, it's been called with two integer parameters and it returns an int, which means I can use a Baz there instead. Obviously the semantics will be different, but the types will be fine.
Okay, so you write them with as the same type.
What do you mean?
So they're the same type. Let's do parameters of bar. I say Baz. Other than that, that would work. Right?
That would mean, well, okay, so, okay, let's answer some questions kind of in turn. So, could you write a function like this?
Probably should. I'm a little deep water work right now. It's my laziness to me.
Right? So now bar is a function that takes in as its first parameter an integer. As its second parameter, it takes in a function that takes in two parameters and returns two integers and returns an integer. And bar itself returns an integer. So the question is this a valid type? Yes. I don't know if it's actually
It's not gonna help. Yeah, it's not gonna help.
I want you to think about it. I want you to reason about it. Reason one way or the other. Right? Make
Are
it
we
an
allowed
argument.
to say it throws an error?
If I gave you something like this, right? What would you say?
I would probably return the A and the B like that.
Like this? This can't possibly be the case, right? Just like we did Project 4.
Hey,
A variable can't be a string and an integer at the same time.
I don't know what the language is doing. It could be something funky.
This is exactly the type system is trying to prevent you from doing, right? Right. So you'd say, or like, let's say, another example, right? Let's say we have foo, right? And then with foo, forget that. Let's say we take in A, right? And we say, if A, right, return A plus 1. Else return 0. Right?
I don't want to start.
So here,
just because I think I cannot.
this means A must be a Boolean. This means that A must be an integer. In our language, you can't be an integer and a Boolean at the same time. So what would you say if I asked you to check this? Type error. And you'd probably explain why, right?
It's valid C code though.
Yeah, I know.
That's
That's because the type system of C
is all int pretty much.
is a little bit more flexible.
Yeah.
It will allow implicit conversions between types. And it actually specifically allows, there is no Boolean in C, right? So
It's
that's
all
actually
yeah.
the big problem,
Yeah.
which is incredibly annoying.
So for all the theoretical stuff in this class, we just don't go with C, but every time it's code based, we think of C syntax. So it just
and
depends.
I won't ever test those weird
Okay.
C corner cases, right? Like, those aren't the things we're interested in. We're just interested in the execution semantics of C. For Hindley-Milner, you need to go off of what we discussed in class, right? That's kind of the language that we built up.
So with the definition from what I'm seeing on one of the problems, I can write code that would work with it. It would just be stuck in an infinite loop.
Then could you write code to work with it?
Yes, it would be in an infinite loop, but it would do nothing in the end. But it would technically.
There's a definer. There's a
say there's clearly a type error. Right?
Yeah.
I said it's a bool. This condition says it's a boolean. This says it has to be an integer. I can't unify those types, right? There's no more specific thing than boolean and integer,
Yeah.
right? I mean, another way to think about it, right? Hindley-Milner needs to tell me what the types of my function are.
I mean,
If it can't tell me that, then the function doesn't type check, right?
I mean, you can figure out the type still. It would just, in the end, it would be an infinite loop.
You can't resolve
But
it.
how could you call that function?
I think it's the order.
Can you call that function? What do you write in here for the types of calling that function? Because each type has to be finite when it's in a variable, right? I mean, D at runtime has to have a finite type,
Yeah.
right? I need to be either array of ints. I can't be an array of arrays of arrays of arrays, right? That doesn't
Yeah.
make sense.
Can I do a function? Can I define a function and then put that in, or no? Like, so I
Yes,
say
that would be another thing, right? Is another way to do this would be like, let's say these are functions that it takes in.
Yeah.
Write one of those functions. Right? Write a function, show that it has that type that you declared for this parameter of food.
Actually, I think we came up with a way to make it not infinite. We can add in new in the hindley-milner. Are we assuming there are no local variables, or can there be local variables in the function?
I mean, it's whatever the function says. We didn't introduce local variables, but they would be the same. You would just declare like a variable. It wouldn't have a type. You just say like var a, and then based on the usage of a in the function, you would infer the type of a. You have to keep all the constraints too that you have, right?
For food, didn't we say that in hindley-milner that we could do reals also?
Yes.
So could we not do a real plus that one and then
Correct.
just numeric?
Yes. So we could not do like 2.0 to 1.
Okay.
If you think about it, right? I mean, the compiler doesn't do this either, right? It doesn't add, because the way it represents floats versus integers does not allow you to just add them together, right? The compiler actually has to know, hey, this is a float, even though they're both 32-bit, right? This is a float, which means it's an IEEE floating point format, which means that the compiler actually, the C compiler is quote unquote smart enough, right, to automatically transform this float into an integer and then add those integers together. So basically it knows that it can do that, and it knows how to transform it. But you could do this, right? You could write a function that takes in a float and returns an integer, right? Like toInt, right? And if you do this, everything works fine, right? The type system
You're
works
giving
fine.
it more specific instructions.
Yes. You are feeding, yeah, because this knowledge, right, of how to transform floats to ints must exist somewhere. It just happens to be in C, it exists in the compiler. So like actually programming in languages that do hindley-milner type inference, they vary based on what they allow you to do. So like Scala, you can actually define functions and say, hey, this function can be used always to transform floats to ints. And then the type system knows that, so then when it sees this call here, it says, is there a function that'll get me from floats to ints? And it will automatically use that. But it makes the code a little bit weird to read.
But wouldn't it kind of like change the second into flow instead?
C? Yeah, it would. I guess I missaid that.
So
But
it's going to return the flow.
no. Hindley-Milner will not, like by default, will not do any of that. It'll just say this, the type system does not allow this. So fail. Kill it.
I have a problem on the project file.
Okay, any other four questions? Project 5 question? Sure, we'll do that too.
Quick
So,
question. Do you happen to have my exam with you?
No.
I missed you.
You have to go to the TA.
So if statement in project file, I assume that when I do the true branch,
You stand here, so.
I just kind of read whatever in the parenthesis, and then I will read kind of like whatever is follow that right parenthesis in the file branch, and then I loop, and then to be able to kind of like ask it to do like a true statement and then the file statement, I will loop the true statement to the end and then link it to the file branch. Isn't that? Did I do it
Then
right?
we get to the false branch? What do you mean by that?
So just kind of like,
You're talking about like a if statement or a while
If statement.
If statement.
yeah, so it's kind of like after you do the true branch,
Mhm.
and you will still going to execute the fails branch, right?
Right. Okay. So in our language, right, an if, right,
Yeah, because fails branches and whatever after that.
but there is no false branch. Right? I mean, there is no explicit false branch
Yeah,
here.
yeah.
So the false branch is basically right the next instruction that's after.
Yeah, it's
here.
the next instruction.
Exactly. So when you call parse body, right? So you should be, this is a body,
Yeah, I know.
right? So you should call parse body here to parse this, so that way everything will happen and you can deal with recursive ifs, right? So yeah, so what you're gonna want to do, right, is make an if statement, right? Make an if statement that's just like you said, right? True branch
Yeah. And then-
is this body,
yeah, and I read a body, and after that I read a statement.
which is statement lists, right? And then the false branch, right? We said we want to actually create this no op statement,
Yeah.
right? And so we're going to put this false branch here. But let's look at this diagram we have here, right? And then there's going to be, so this returns, right? We're going to return essentially a pointer to this if statement. And then our parse statement list is going to create, like, I don't know, the next assign statement or whatever, right? And it's going to set this one's next to this assign statement, right? But look at what this picture we've just drawn, right?
Yeah, no, we also link the true branch to the next.
Exactly,
assignment.
that's the key. Yes, we need the true branch, right? We need to, when we get the body only parses what's inside here. So the last statement there has no next pointer.
Yeah, I know. It's exactly what I do, but however, in the program that after I execute my true branch, I don't know why it doesn't go to the next assign statement. Like, it doesn't sound any difficult to do, links one link list to the end of another link list. Like, it's nothing difficult about it, but in my code, it doesn't work. I don't
Is
know.
it actually the same not statement? So you gotta look and see, is the last statement list here, or statement node in your body with the true branch, does it point to the same not statement that you're using here?
It should.
You should check that. Like one problem would be if you make a new not statement, you malloc a new not statement, right? They're gonna go to different places. So you need the false branch to go to the same place, you need the true branch to go to the same place.
The
And
thing is like, I define my new statement kind of like outside the true branch, so it's kind of like I call the get body methods to kind of like get whatever is in the true branch, and then so after that function returns, I create a loop, the loop statement, and then I will set the new statement the next to call like whatever, call a stimulus to kind of like get whatever is after that. And then I will have the fail statement points to the new, and also have the end of the choose branch points to the new.
but you shouldn't be calling, right? Your if statement should only parse an if statement. It should not be parsing what comes after it.
I mean, kind of like whatever after this, kind of like.
But the if parse if should not parse what comes after it, right?
Yeah.
Parsing if should only parse this right here. Right? It should only parse these. It should not call parse statement list to parse everything that comes afterwards.
No.
No.
So how am I supposed to kind of like link my?
Exactly. The
finite
problem
list
is
to
this
the next
no
assignment?
ops, exactly. Right? Just like you're doing it normally, right? So this is actually a statement node, and we put in the pseudocode that the statement node, right, this has a pointer to this if statement,
Yeah.
and we have its next be this no op, right? That's what we said in the pseudocode we should do, because when you call parse statement, it's going to return this, but unlike normal statements, right? Normal statements, we want to set the next of a statement equal to the next one of the statement list.
It's still, I think it's still exactly what I did. It's like, I think I call my new in the kind of like the statement list kind of like, so I didn't set the new, I didn't call the list in in the if statement instead of kind of like I left it outside, so it will kind of like still have a structure like that.
But will it? I mean, this is what you have to verify. Like, you have to verify that this actually has this structure, right? The key is this link here, right? The parse statement, when it sees that it got an if statement back, it needs to set not the next equal to the next instruction, right? Because honestly, this pointer doesn't matter at all, this next, right? Because we're going to go in the if statement, right? It's going to go here. What we want to set is the next to point to the next instruction.
Okay, I would check with that.
Yeah, check the pseudocode. If you try to match up the pseudocode with your code, you can hopefully figure out what's going wrong. And then you need to like debug your code or go through it by hand and draw this structure and be like, okay, what exactly is happening at all these points? And the other key is you want to make sure that your if condition, your parse if statement does not parse anything afterwards.
Do that.
Okay, just for you and everyone else. But I have to go here in class. Maybe like one question.
Okay. Yeah.
Wait.
So just look at my diagram for the switch statement here. So we start with like a statement node when you enter it, and then it's gonna be representing as an if switch. So then you're gonna have two branches for that if. It can be the true branch falls or false branch falls. So if that if statement falls, the false branch is gonna parse the body, come down through whatever statements are in it, and the last thing you're gonna point that to is going to be a go-to to the no-op statement off the next of your original statement node. But if it was a true, then it links that true statement, true branch of that if statement to a new statement node here, which would follow the false branch, go here. And at the very end, if it doesn't find any matches and there's no default, it would have, well, this would be a go-to statement, so it's not, but should be go-to, which would read all the way over down over to here. So that would be.
Yeah, that should work.
Okay.
And because you already have the logic of the if statement to do this mapping, right? So when it parses, when you return that, it will set the next to be whatever the next instruction is. And so we'll properly set that up.
Okay. Awesome.
Cool.
Thank you.
Just do it.
You have to go. We can walk and talk to some about
Okay,
class.
cool.
Can I ask a real quick question?
Like 1 minute.
Okay. So, can we define a function that takes it? Can I do this? Just that. I came up with a valid code for this, but that's not important. Can I do that?
What does the function look like for that? What is that? So
Like,
the second line? F?
yeah, basically the two of those together.
So is it defining
The two of those
type
together? So F is what?
A type.
F is a function.
So what's the type of F though? Type of F is what?
A
function that takes in what?
takes in another type F.
And returns a Boolean?
Yes.
Cool. So write a function that does this.
Should zoom.
Okay, wait.
But that doesn't.
It takes in D. It could be that type.
But
why is it not
is
zooming?
it that type? Because D doesn't return a Boolean.
I mean, for all we know, it does. I could make a D function that returns a Boolean, but the point is, it doesn't need to even be called. You can still return true or
but
false.
D we need to know the type of D, right? And D has to be a function to be able to be passed into there.
I mean, I do use D up here, and I use it in the same way. This would be a valid thing according to our language, and
So these are valid, right? But this function A has the type A where it takes in anything T1 and returns a Boolean,
yeah.
right? But when you pass it in here, it can't be just anything. It needs to be a function that takes in an F and returns a true, right? So like here, your function C, right?
Yeah.
What's T1 and T2? Let's say Booleans or something.
Yeah, they're just type T, because
Okay.
C can be anything from the definition.
Right, so how would you call function C? Like, what do you pass in as D here? Like, maybe you could define these functions, and the way you've defined them, you're right. The way you've defined them has the type. So, like, the type of A is T1 returns a Boolean, right?
Yeah.
But how do you pass in, like, that's,
Are we actually passing in a function, or are we just passing in the type?
it has to be a function, right? This tells you
Yeah.
that this has to be a function,
Yes.
Yes.
right? So can you pass your A into, let's just say like a bool, into this, call this F with it. Right, so if we have A, the type of A is this, the type of F is this.
Mm-hmm.
Right, can I actually call that? I mean, A, like I need to know what this type T1 is, right? So like to use this, what does this mean about the type of T1?
That it has to be a function that returns a Boolean also. Well, it means that it can be anything. Like
This means
literally.
it can be anything, but using it here means that it has to be what?
Predefined.
Right, so like up here, when I had, I'm gonna be late to my class.
Sorry.
It's okay. No, this is important. Right, like here, right, when I call foo here, this function foo, right, which takes in a T1, T1 returns a T1. When I call it here with D and E as both integers,
They're
right,
both integers.
it means that T1 has to be an integer
Yeah.
for this instance, which is how I know that it returns a T1. Similarly, right, the same thing happens here. When I try to call this function f with a, it has to, what does the constraint of type 1 have to be for this to hold?
I don't think there is a constraint since it's not. It doesn't end up being used. I mean, there would.
But we want to know if it's correct,
The-
because maybe there's other constraints. Like, it doesn't matter that it's used or not used,
Yeah.
right?
It'd be like the most generic possible, whatever top level that would be.
But we want the most specific, right? We want the most specific type, right? So normally, if we pass this in here, right, we say, okay, this is my parameter that I'm passing in.
Mm-hmm.
This is the parameter of the thing that I'm passing in, right? So
Yeah.
this means that TF is T1 goes to Boolean,
Mm-hmm.
right? So, but what is TF?
That.
So can we not define types like that?
Right, but what is TF? Well, TF is also, so for this to be correct, right, this would also have to be T1 goes to Boolean,
Mm-hmm.
right? But this T1 is also a TF, so it would also need to be TF.
Yeah.
T1 goes to Boolean.
Boolean goes to Boolean.
So am I ever going to stop?
No.
So would this be a valid type that I could write out?
Not annually.
Not manually, even if a computer did this, how long is it going to go?
It will go infinitely.
Infinitely. All right, I got to go, yeah. So if you can't write that type down, you can't call that function.